Hello. In this episode, I'll show you how to set up Flyte on Azure using the recently released Terraform scripts. So, the first thing is to show you the general structure of what it gets deployed when you run these modules. By the way, this has been tested with both OpenTofu and Terraform. So in general, it will automate the deployment of all the prerequisites for Flyte or the external dependencies for Flyte. In this case, it's mainly the database or Azure database for Postgres and also the blob storage piece. And it will deploy the Azure Kubernetes cluster and configure everything necessary for workload identity federation to work with Entra ID. And additionally, for connectivity and security, it will deploy the Nginx ingress controller. It will automatically connect this with the Azure Load Balancer instance and the TLS lifecycle management for the certificates for a secure connection between the client and the server. And it will give you just the endpoint to using your local Flyte config file, and you're good to go. So the main thing is that in this episode, I will demo the whole process. I will follow the steps in the README, and you can follow along. If you have any questions, you can drop it in the question section in this video. You can go to the Flyte Slack and go to the Flyte on Azure channel, and you can find us there. So yeah, let's move to the demo. All right, so yeah, this is not the right. Cool. Yeah, let me move to the right screen. There you go. So the Terraform modules can be found in this repo, the deploy Flyte under the Union AI OSS org. And there you can find Flyte on Azure. There are modules also for two other main clouds. In terms of prerequisites, you need to have performed the Azure CLI login. And once logged in, you need to create three main things: a resource group, and a storage account with default settings inside that resource group, and a storage container where we will store the Terraform state, right? So because this is run before Terraform or OpenTofu can execute the modules, we need to create this as a prerequisite. So I will do it right away. Let me see. Yeah, there you go. So I will create a resource group for this demo. We see group create name. Let's call it Flyte School. And location where I'm running this is US2. There you go. Cool. And now I'm going to create the storage account, which is the next thing. Is AZ storage account create. That's just help. No. That's just name. I will call it also Flyte School, right? And resource group is the one that I just created, Flyte School, and location is US2. There you go. Okay, it's done. And finally, I will create a storage container. No, I'll call it Flyte School 2. And we'll do it in our new resource group, which is Flyte School. There you go. Okay, storage account name. Oh, yeah. And let me do it. This account name, Flyte School. There you go. Okay, with these three things created, the next thing is that I need to go to backend.tf bars and set these values there. So I have here the contents of the repo, and I will set here Flyte School. Storage account name is Flyte School. And guess what? This is also Flyte School. I'll leave the rest as is. And there you go. So we can do an init, the full init backend equal true. Backend config equal backend dot where I am. Let me see. Yeah. So tofu init backend equal true. Backend config equal backend. Sorry, this is reconfigure. There you go. And here I'm using tofu from OpenTofu, but it works the same if you're using just Terraform. There you go. So everything is good. So now we'll do a plan, tofu plan. This is where things get verified. Okay, so the Azure region, in this case, this is ES2. Subscription ID, I'll put here my specific values. There you go. So the tofu plan looks just all right. And it's just three variables that will ask: the Azure region, subscription ID, and tenant ID. And I'll do an apply the plan, and we can wait. In the meantime, I want to just show you, let me move to a different screen. Okay, there you go. We just publish a new blog post that goes about a bit more in detail on what happens in the background and especially why some of the design decisions behind these Terraform modules that for us are more a reference implementation on Azure is not the only way to deploy Flyte on Azure, but is one that follows a certain criteria of security, of reliability, um, and if you apply this in your environment, or at least you use it as an inspiration to build something else on Azure, it will give you a good idea of what a production grade Flyte deployment looks like. So yeah, the first thing to say is it has it all of this was built with the support of the community, including folks from different companies who kind of forced the way for the actual compatibility of Flyte with Azure. And yeah, one of the key pieces was to enable Flyte at the multiple layers to be able to interact with Azure storage. And so that was one of the main pieces. The another piece is the relational database. As I said, is one of the external dependencies for Flyte, and these modules will automatically deploy an Azure database for Postgres version 15 with specific compute configuration that you can control. You can go here to the things the Postgres.tf module, and you can control the instance type. Here we are using this one, which is pretty small. Uh, but before considering scaling up resources on the database, there are other um, flight other performance tuning um, strategies that Flyte provides that are covered in the docs. For us, the crux of the matter or the core of the solution is the identity management piece. It was very important to be able to not only access, read and write access to blob storage, but do it in a way that is secure instead of relying on secret keys, storage account keys in plain text or something like that. We wanted this reference implementation to use federated identity credentials integrated with or provided by Entry ID as a mechanism to handle identity of all the workloads in the AKS cluster. So the kind of the blog post covers the story and how this is implemented by the modules. The code is here in the IAM module, and it's a multi-step kind of process. I think the summary is here. It's similar to how it works in other cloud providers in terms of you have a Kubernetes pod that uses a service account. In this case, every um, flight execution by default will use the default um, Kubernetes service account on each of the namespaces where execution is running. So the Terraform modules will annotate the service account in a way that points to, in this case, the federated identity credentials. Uh, and in this case, it's a app registration. There is one for the user execution pods that is called Flyte User, and there is one for the Flyte backend components, I mean Flyte Admin, Flyte Propeller, and Data Catalog, which are the components that need access to storage components. And using this Enter ID, we'll be able to emit a token for the OIDC flow to complete, and then use this identity. The pods will be able to use this identity to request access to other Azure resources, but particularly is to get access to the storage account. And with a specific role, in this case being the data owner role, be able to read or write on the Azure blob storage container piece, right? That is kind of the overall process. Again, if you're familiar to how it works, this IAM for Kubernetes service accounts in other providers, it's very similar. But it has some nuances, especially in Azure, because there are two different APIs that operate at two different levels, the Azure RM and others that. So having this in mind, the blog post cover details on how the process works and how it was implemented. At the end, what you see is that every execution will have injected. This is injected by a webhook that gets activated or installed in the AKA cluster, AKS cluster when workload identity federation is working as expected. It will inject these environment variables that will constitute the identity this pod can use on Azure. Okay, all this happens automatically. I mean, you can inspect the contents of the IAM files. You can see that we're using the Azure RM API heavily here for the different resources. The different steps that are covered in this diagram are here. And this is the the most granular permission we were able to convey for this reference implementation. Probably if you need to make it even more granular, you could move to a custom role here, for example, and that at the end this role gets assigned to either the user or the backend application that gets registered. And yeah, that's it for the IAM side. In the compute layer, we have, yeah, by default, a node pool that gets created on the AKS module with one node, up to 10 nodes max. It's what we call the CPU pool. And if you need to use GPUs um, available on Azure, you can instruct Flyte to deploy also a GPU power node pool that will live under the same AKS cluster. And you can do so by moving this field here. I mean, the node pool count by default is 0, meaning that there will be no GPU nodes here. But if you move this to something different, then this will kick off the creation of multiple resources. Uh, Once you move this from 0 to another positive number, you need to instruct Flyte with the GPU machine type. This is the Azure instance type that you're going to use for a specific GPU model. This is for the A100s. And for this, you need to use one of the supported options by Flyte. In this case, I'm instructing Flyte to use the A100, but there are other models that are supported. The nice thing here is that this enables your users to just request with a single task annotation from your Python code to request specific GPU resources. The blog post gives you more details and include links to the documentation that gives you even more details, right? The A100 is special one because it supports partitioning. So if you plan to request partitions, you can instruct Flyte here with the partition size. And you can also add additional things. So that's probably the only things you need to configure if you need to use GPUs. The rest is automated. You can see right here that even the labeling is automated. The node pools created here, and the NVIDIA GPU operator is installed and configured automatically if you set the node pool to something other than 0. And the operator will automate the installation of the device plugin driver and daemon set and all the components necessary. So the Kubernetes API will know that there are GPUs available in at least in a node pool in the cluster, right? And now the Kubernetes scheduler will be able to fulfill GPU requests, right? That's for the accelerator part of things. We can see that this is now installing the Helm chart, the Flyte core Helm chart. Let me see. There you go. Yeah, installing the Helm chart. Um, and finally, to secure your workloads, or at least to provide, scalable connectivity and secure connectivity between the client and the server, the Terraform modules will automatically deploy an ingress resource or request an ingress resource that will be fulfilled by the Nginx ingress controller. And it will configure the Azure Load Balancer instance, the public IP, and the DNS label. So the endpoint that you receive by the end of the execution of the modules, it will be the one you can use right away to connect to Flyte through Ingress and using a TLS certificate. So this all happens automatically. This is covered here in the Ingress TLS module. But yeah, it will deploy everything, the Nginx controllers, hem chart, and also the CRDs for server manager that have to be um, deployed or created as from kubectl. That's the recommendation from the server manager team. And also the server manager Azure that will again listen to requests for certificates, and it will fulfill those requests. So probably the only thing you will need to customize is go to locals, and there's here the email. You can change this to an actual email that you have access to, because Let's Encrypt will send an automated email there when the certificate is about to expire. So it's important um, to set this correctly. The other things that you could probably customize is here. I mean, you will see that in the resources that get created, everything follows this this structure, like flight, domain label, and environment. And you can change this, and it will just change the naming of the resources. And also the projects. These are the default projects that Flyte will configure. And with this, it means that it will not only create this namespaces combination in flight snacks dash development dash staging production, but it will also configure the annotation. If you remember the annotation for the service accounts at each one of these namespaces. If you need more projects or different domains, you can configure that here, and and run the modules again, and it will configure the annotation for the default service account at each one of those new namespaces. So that's interesting. Cool. Yeah, it's taking some time. Cool. And finally, this was a need, especially when we were testing the GPU component, storing images in Azure Container Registry. And yeah, whenever you need to customize the container image that Flyte uses to run workflows, you can do it and push your content to the Azure Container Registry. So you don't need to do anything about this. By default, Flyte will not only create an ACR instance, but it will grant every workload in the AKS cluster will have permissions to pull from that repo. And you can the README in the repo will show you how to configure yourself as client with the permissions to push to the container registry, so you can push images, and the pods in the cluster will be able to pull down those images, right? In terms of permissions, everything that is required, it's configured automatically for you. Cool. Right on time, because this thing already finished, and you can see the only output here is the endpoint that you can use. One thing that I tend to verify, and I know this depends largely on DNS propagation time, but seems like it's already there. The fact that this is working means a lot of things, but means, in among other things, that that mapping of the um, ingress resource, the public IP, and the DNS label, or this name mapping to the public IP address assigned to the load balancer that is assigned to the Kubernetes ingress instance is working, right? So if I go here, let me use US to, let me see, and there you go. There is Yeah, nothing is running there. We can just let me see, flight. I will verify that my local config file is pointing to my new flight deployment in Azure. Insecure, I will say it's false because it's using certificates, so it's not insecure. I'll check right away that I can communicate via gRPC with Flyte on Azure, which is the case. So let me see, do we have something here to test this? No, probably not, but um, let me pull up a workflow so we can test. There you go. So we can just say run mode Azure test one. Simple workflow. And here it's running. It's a fairly simple, but kind of tests all the plumbing below the connection from stow to the blob storage and all this, especially this step. And yeah, still working on it. We can see if thing looks all right. Should be a pod. There you go. It's running. Um, just if you're curious, you can see the actual spec that the pods ended up having, and it should have all these Azure related environment variables. There you go. So this is workload identity federation working as expected. You can see a token for Azure was injected and mounted as a volume. And yeah, the first task succeeded. So that's it. That's the summary. This is how you can run Flyte on Azure easily. Hope you like it. If there's any other question, again, drop it in the comment section in this video or go to Slack, the Flyte on Azure channel. Thanks for watching.